Welcome to EDU World Space.
Okay, let's go ahead and do this problem. We're given the integral of 1 minus 8v cubed plus 16v to the 7th dv. So in order to evaluate this expression, all we need to do is to utilize these two facts. The power rule of the, not the derivative, the antiderivative of the integral, and the second part of fundamental theorem of calculus. So let's remember this portion. V to the nth power, when you take the derivative, you will get nv to the n minus 1. So the power is reduced by 1, and then you multiply n, right? So because this is an antiderivative, you go in the opposite direction. The first thing that happens is that the power is increased by 1, and then instead of multiplying the number that you had in the exponent, now you're going to be dividing by the number that you have in the exponent. So this is the expression that you're going to get. Next, the fundamental theorem of calculus basically says, once you find the antiderivative, all you have to do is to plug in the b and the a in the way that it's going to be a subtraction of the antiderivatives. So this is a very powerful fact that makes all of the calculations easy. So let's apply it to this problem. The derivative, the integral of 1 is going to be v. V cubed, the integral would be v to the fourth divided by 4. So you will have minus 8v to the fourth over 4. The next expression is going to be 16v to the eighth over 8. And then you're going to evaluate it by plugging in the numbers 0 and 1 later. Now, when I plug in 0, you can see that all of these expressions are going to be 0, so I am not going to worry about it. And plugging in 1 is also quite simple. So you just need to say this is 1. 8 divided by 4 is 2. And 16 over 8 is also 2. These two terms cancel each other out. So the result is 1. And this is how you solve these kind of problems.